Welcome back to another video. Today we're going to show that 21 divides 4 to the n plus 1 plus 5 to the 2n minus 1 for any positive integer n. So we have to use the mathematical induction. So we start with this proof. And I will let Pn be this statement. So our Pn is now 21 divided 4 raised to the n plus 1 plus 5 raised to the 2n minus 1. So to use the mathematical induction, we have to start with the base step. For the base step, we have to plug in n equal to 1 and see if P1 is true. So we're going to have 4 to the 1 plus 1 plus 5 to the 2 times 1 minus 1, which is 4 to the 2 plus 5 to the 1, which is 16 plus 5, which is 21. And it turns out to be 1 times 21. Okay, so what do we have right here? We're going to have 21 divided 4 raised to the 1 plus 1 plus 5 raised to the 1 times to the 2 times 1 minus 1. Okay, so that means that 21 divide this term, so P1 is true. Okay, now P1 is true. What can we do next? The next thing that I'm going to do is to do inductive step. Okay, what is inductive step? For inductive step, we have to assume that PK is true for any positive integer k. And we have to show that Pk plus 1 is true. Now, since Pk is true, what do we have? So since Pk is true, so we have to plug in k to in here. So we're gonna have 21 divide 4 to the k plus 1 plus 5 to the 2k minus 1. Okay, so this is what we have. We gotta have integer q such that 4 to the k plus 1 plus 5 to the k minus 1 equal which one? 21q. Okay, 21q. So what do we have? So we gotta have 4 to the k plus 1 plus 1. So we want to show that k plus 1 is true. We gotta have k to the 4 to the k plus 1 plus 1 plus 5 to the 2 times k plus 1 minus 1. Okay, so we're gonna have 4 to the k plus 2 plus 5 to which one? 2k plus 2 minus 1. And then we gotta have 4 to the k plus 2 plus 5 to the 2k plus 1. Okay, so I want to use this statement. So what I have to do is to try to have 4 to the k plus 1 and 5 to the 2k minus 1. So in this case, we gotta have 4 to the k plus 1 times 4. Okay, I forget to multiply it by 4. And 5 times 5 to the 2k. Okay, so we're going to have 4 times 4 to the k plus 1. What happened to this one? What I want to have? is this term 5 to the 2k minus 1. So I want to have this right hand side to have factor of 21. So right now I gotta add 4 times 5 to the 2k minus 1, okay, plus 5 to the 5 times 5 to the 2k minus 4 times 5 to the 2k minus 1. Okay, so what do we have right here? We factorize number 4, so we gotta have 4, okay, 4 times 4 to the k plus 1 plus 5 to the 2k minus 1, okay, and plus 5 times 5 to the 2k minus 4 times 5 to the 2k minus 1. Okay, what about this term? This one right here is 21q. So we have this term to have 21 as a factor. So right now we have these 3 terms. Now what can we do next? We want to have this term to be divisible by 21. That means that I have to show that this term right here is divisible by 21. So let's have this one. 4 times 21q plus 5 to the 2k plus 1 minus 4 times 5 to the 2k minus 1. So I have to show that this term is divisible by 21. So I have to claim that. Let's claim that 21 divide 5 to the 2k plus 1 minus 4 times 5 to the 2k minus 1 for any positive integer. Let's use n. Sorry, let's use n. Okay, 5 to the 2n plus 1 and 5 to the 2n minus 1 for any positive integer n. Okay, let's do this. So we use the principle of mathematical induction. So we gotta let qn be 21 divide 5 to the 2n plus 1 minus 4 times 5 to the 2n minus 1. Okay, then what do we have? We start with the base step. For the base step, what can we do? So we have to let n to be 1. So we're going to have 5 to the 2 times 1 plus 1 minus 5 minus 4 times 5 to the 2 times 1 minus 1. Then it turns out to be 5 to the 3 minus 4 times 5 to the 1. And it turns out to be 125 minus 20, which is 105. And 105 is 5 times 21. So this term is divisible by 21. This means that 21 divide 5 to the 2 times 1 plus 1 minus 4 times 5 to the 2 times 1 minus 1. Okay, so Q1 is true. Okay, Q1 is true. So the base step is proved. So let's go to inductive step. Now take a look at the inductive step. So we have to assume that Q of k is true, okay, for any positive integer k, okay, and we have to show that Q of k plus 1 is true. Okay, so since since Q of K is true, what do we have? Okay, so we're gonna have 21 divide 5 to the 2 to the K plus 1 minus 5 or minus 4 times 5 to the 2K minus 1. Then what do we have if we have this division? So we gotta have integer, let's say Q sub 1, okay, such that 5 to the 2K plus 1 minus 4 times 5 to the 2K minus 1 equal 21Q1. And then we try to show that Q of K plus 1 is true. So what do we have right now? Right now, this is what we have. It turns out to be 5 to the 2 times K plus 1. Okay? And plus 1 minus 4 times 5 to the 2K plus 1 minus 1. So what do we have right here? We're going to have 5 to the 2K plus 3 minus 4 times 5 to the 2K plus 1. Okay. Then what do we have right here? We're going to have 5 to the 2 times 5 to the 2K plus 1 minus. Okay. Minus. Okay, what can we do with this? Let me think about it. We want to have 2 to the K minus 1. That means that we're going to have 5 square. Okay, times 4. And then 5 raised to the 2K minus 1. Alright, so let's factorize 5 square. So we're going to have 5 square times 5 to the 2K plus 1 minus 4 times 5 to the 2K minus 1. And this term right here is 21Q1. So it turns out to be 5 squared times 21Q1. Okay, so we're going to have 21 times 25Q1. That means that 21 divide this term. Okay, therefore, we're going to have 21 divide 5 to the 2 times K plus 1 minus 4 times 5 to the 2 times K plus 1 minus 1. Okay, so that's what we have, right? So that means that Q of K plus 1 is true. So we have the inductive step already. Therefore, 21 divide 5 to the 2n plus 1 minus 4 times 5 to the 2n minus 1. Okay, is true, which means that this number is divisible by 21 for any positive integer n. Okay, now here's what we have. Therefore, what do we have here? So there exists, okay, let's say positive integer r, not positive integer, it's just integer r, such that 5 to the, right here, okay, 5 to the 2k plus 1 minus 4 times 5 to the 2k minus 1 equal 21r. Okay, that's what we have right here. Therefore, from this term right here, we go back to the problem we want to solve here. Equal to which number? Equal to this one here. Okay. And this term turns out to be 21r. Then it turns out to be 4 times 21Q plus 21r. So So we're gonna have 21 times 4q plus r. Okay, so we have shown that 21 divide 4 to the k plus 1 plus 1 plus 5 to the 2 times k plus 1 minus 1. Okay, so we have shown that p of k plus 1 is true. Okay, p of k plus 1 is true, and therefore 21 divide 4 to the n plus 1 plus 5 to the 2n minus 1 for any positive integer n. Okay, so that's what we have right here. That's the proof of this divisibility. So that's for today, and see you in the next video.